So now let us try to figure out what are the next things. So we refined the physical connectivity things, and we have seen some of the commands like show interface status and show IP interface brief commands, very useful commands for testing the connectivity. Now we'll see the switch configuration. Sometimes misconfigurations on your switch can also affect your packets drops. Let us see what are those things. Like I got a simple scenario here. If you try to read this scenario, there is a user sitting here. It's trying to access some server on a different switch. It's on the same LAN. When he's trying to do that, the user PC1 has been transferring a very large files from here to here, and the maximum throughput is 100 Mbps because this port is 100 Mbps, 100 Mbps and 1 gig. So easily he can send 100 Mbps of data within the LAN. So now what we want is, we want to make sure that transfer of 1 GB of information at the rate of 100 Mbps will not take more than 80 seconds. So but here the problem here is congestion on the network, underperforming the hardware of the client and network or server. So these are some of the potential explanations. Generally we say there is some congestion on the network, devices are not performing as per their speed, the client, server, all these things. So the average load on the links in the path has not been higher than 50% over the last few years, so ruling out the congestion as a cause. So now this is the scenario. So whenever you come across this type of scenario where you can send 100 Mbps speed and you are transferring 1 GB of data, it will not take 80 seconds more than that, but it's taking very huge amount of time. So typically the problem will be with a duplex mismatch. If you have a mismatch of duplex, then this is the most likely reason for this type of issues. So mismatch of the speed and the duplex configurations will definitely affect your communication. So they will communicate, but again it will affect the throughput of your communication process. Okay, so by default speed is auto. In general, when you verify the configurations on any device, the speed will be auto, and that's what auto negotiation we call as. Duplex is also auto. Auto means, like in general we have two types of communications, let's say. So let's take an example here. There are three types of communications. So if there is a mismatch of duplex, like take an example, this device is configured with half duplex, and if the opposite device is configured with full duplex, then it might affect your communication between these devices. So let me first explain you the three types of communications here. Simplex is simply a one-way communication where we only send but we don't receive anything. So simplex devices, examples like TV, television, radio, these are some of the simplex devices. We don't do any much communication of simplex here. So we have two types of communications much in common. We call them as half duplex and full duplex. So half duplex means we are having two-way communication but not at the same time, which means just like walkie-talkie, you can send but you cannot receive at the same time, but once it finishes you can send. Full duplex means sending and receiving simultaneously. Now most of the devices, new devices like our new switches and PCs, all the devices, networking devices support full duplex, which supports high-speed data transfer rates. But if you take some of the hubs and some of the older switch models supports half duplex. So if your mismatch of this duplex settings, so by default settings will be in each and every device we have something called auto. So the meaning of auto is auto negotiation, where if this device supports full duplex, if other device also full duplex, then automatically they work on full duplex. So let's say if one of the device is supporting half duplex, let's say the switch supports half duplex and maybe the device supports full duplex, but if you keep it auto means automatically both the devices will work on half duplex. But misconfiguration of this, so there are multiple options we can use. Either we can use auto option, or we can use half duplex, or we can use full duplex depending upon the option. Let me show you that. I have a switch here. In my switch I'm going to show you the configurations. I'm going to switch one, and when you use question marks you'll find multiple options here. The first option is you can define the speed. So by default, if I check my running configurations, if I give show running configurations, you can see there's nothing configured. So whenever you see nothing is configured, the simple reason is it is just using the auto process. So I'm going to my interface mode. I'm going to define the speed. So typically this is a fast Ethernet port, so by default it supports 100 Mbps, but we can define is auto means auto negotiation. So in case of auto negotiation, what it will do is, if one device, this device is supporting 10 Mbps and this is supporting 100 Mbps, they automatically work on 10. Okay, but if you configure one side of the device as 10 and the other side of the device as 100 manual speeds, in that case it will affect, because this device is going to send the information at a speed of 100 Mbps, but this device is only capable of receiving 10 Mbps, means automatically it is going to drop the other packets. So that is what we call as late collisions. So speed mismatch or duplex mismatch will affect these things. So you have to make sure that on both the sides, when you are communicating, you should not have a mismatch of these parameters. So I'm going to use speed auto here, or you can just change the speed also, like I'm going to change it to 10, and there is something called duplex command, and using duplex command, either you can leave it to auto is something which is default and it always recommended to leave it to auto, but even if you want, we can change it to half duplex or full duplex. So mismatch of this duplex will definitely affect your communication. So typically you'll find this type of messages, like I got some sample output here. When you verify this, when you use a command called show interface f0 by 1 include duplex, you'll see something called FCF errors, frame check sequence errors. So this number will automatically increase as more and more packets will drop. This might be the reason for your duplex mismatches. And also you'll see something called late collisions happens. So you'll see this number automatically increases as because of these things. So make sure that whichever the port is dropping, so find out that port and verify that there is no duplex mismatch. So you really don't get into this type of things, but when you're connecting some devices which supports full duplex, half duplex, always make sure that use auto mode. Auto is the recommended mode in general, so it really not recommended to change any speeds or duplex settings, but if mismatch of these settings happens, then you'll see this type of issues might occur. So this is what relating to switch configurations. Okay, so physical connectivity we did, and this one, and finally before we finish, I'll just give you one of the good feature of the new recent iOS of Cisco's devices. From iOS 12.2 there is something called auto medium dependent interface crossover. Like as per our normal studies, if you remember, we learned that we need to have a cross cable. Generally, if you want to connect a router to a switch, we use a straight cable. Switch to PC, we use a straight cable in all these cases. And similar way, if you're connecting switch to switch, similar devices, or switch to or PC to PC or PC to router, we use a cross cable. Now depending upon the receiving signals and transmitting signals, it is mandatory for you to use the straight cables here in this case and cross cable in this case. So these are all basic things which we learned already. Now there is a feature called AutoMDIX, which we call as auto medium dependent crossover. Now when you enable this feature will automatically detect the required cable connection, whether it is straight or cross. So which means if you're connecting a router to a switch, so it's not really mandatory to use straight cable, you can just use any type of cable and it will automatically detect. But this feature is by default not enabled. But one more thing, you need to enable this feature, and this feature is supported from iOS 12.2. so this feature, to work this feature, so if one of the two sides connection supports AutoMDIX, you can use crossover or you can use straight through Ethernet cable. Both the cables are going to work. But one thing we need to keep in mind, this feature is going to work only if your speed and duplex settings are set to auto negotiation, which is default. So make sure that you enable the speed and duplex settings to auto negotiation before you do this. So this feature has to be manually enabled using a command called MDIX. So I have a commands here. You can see the first thing I'm using on F0 by 1, or you can use a range command. I'm going to shut down it, enabling the speed and duplex settings to auto mode. Okay, and then I'm going to enable MDIX auto. and finally no shutdown command. So make the interface up. So this is one of the most common feature which most of the people generally use in the production networks, where they can use either of the cables for connections. So finally, before we finish, let us quickly summarize what we discussed here. Now there are two types of end user connectivity. Whenever you realize that the user in the LAN is not able to communicate with another server or another computer in the LAN. So we're not discussing any VLAN configurations, trunking. We'll be discussing in detail about those troubleshootings in our next videos. So here I'm just focusing only on these two things, where there might be a physical connectivity issue, or it can be some misconfigurations on the switches which might affect like duplex mismatch or speed mismatch. These are some of the things which will affect the communication. So in the next video we'll see how to troubleshoot your VLAN configurations. So thanks for watching.